Okay, Serena plans to invest $2,500 into a savings account. The APR of the savings account is 2% and it's compounded daily. And then we have several questions to answer, like how much money she's going to have in several years, and then some other stuff with this particular problem. So let's break down the information we are given and sort of plan our problem solving from there. So first off, we have the amount she invests. She invests $2,500. Notice it doesn't say anything about that happening more than once. So we're going to assume that this is a lump sum problem, meaning all of that money is getting invested at one time, not a regular payment occurrence account. So what that tells me is that I'm going to have a PV value. So I'm going to put that negative 2,500 for my present value, but my payment amount is going to be 0. All right, next up, I'm given that annual percentage rate, and that is 2%, and it's compounded daily. So daily means 365 times in 1 year. And so remember, we treat the payments per year and the compounding per year as the same value, which is why I filled in that P/Y. And I have that interest rate of 2%. Last but not least, let's look at the end value. So we are told how much money will she have? Money she will have. So I'm looking for a future value. That's going to be my question mark. But I then know I'm looking 5 years in the future. So I would take those 5 years and remember that my interest is being applied 365 times each of those 5 years. So now that I've sort of planned out what I need to put in my time value money calculator, I'm going to go ahead and do that. And I have the same calculator you guys do pulled up, just so you can sort of see how I enter the numbers. So I start with my N, and notice I put in the multiplication problem because when I go and move away from the box, it does the multiplying for me. So why do that extra work? I like to make my present value negative because it's taking money out of my checking accounts, or Serena's money out of her checking account into her savings account. She no longer has access to that. And then if I fill in the P/Y, it automatically fills in the C/Y. And last but not least, I say solve for future value. Make sure you get both decimal places for the money. So we have $2,762.92 is the amount of money she will have in 5 years. Now, how much money did she deposit? Well, since this is a lump sum account, she simply deposits her PV value. So in this particular problem, we are just looking for that PV number, which is 2,500. And so we can use that 2,500 to find the net gain and the total return. Remember, net gain is just a fancy way to ask for our absolute change. So we want to take the future value and subtract that present value. So, our net gain will be $27,662.92 minus the 2,500. And for this, you may need a normal calculator for it. You should wind up with 270. Oops, sorry. Doing my math wrong. $262.92 as my net gain. Total return, remember, is just a fancy way to ask for your relative change. I'm going to switch colors again. So total return. And so you take your absolute change, that $262.92, and divide it by your original amount. And we want to turn that into a percent. A very common error here is 1, multiplying by the wrong thing, but then 2, not turning it into a percent. And so it does end up being 10.5%, and that is an increase, and this is also an increase. I should put an increase there. All right, next up. What is the APY of this investment? So remember, with APY, we can think of this a few different ways. So one, we can think of it as our annual return, which I personally find the easiest since I already have two values. And so the annual return, remember, is your newer value divided by your original value. And then we're going to raise that to the 1/5 power. And the reason it's 1 fifth is because that is the number of years that went by between my two amounts. And then I'm going to minus 1 and times the whole thing by, because that takes out the 100% growth factor. And then I'm going to times the whole thing by 100. Because again, just like with our previous problem, we want to turn this into a percent. And your answer should be pretty close to your APR. And you'll notice in this particular case, we get 2.02%. So we got that extra 0.02%. It's not a lot, but it's a little. So, take it and run with it. It's extra money you earned from that compounding daily. All right, last but not least, we are being asked when her investment will double. So a good strategy here is we can actually use our TVM solver. So the trick's going to be, we know what our future value is this time. We want our future value to be double the amount she started with, which is $5,000. And the PV will stay the 2,500. And the PY will stay 365 and the I stays 2. But this time, since we are looking for how many years, we are looking for an N value up here. That's our question mark. And so I'm going to go back to my TVM solver. I'm going to clear that out. And I'm putting in 5,000. And notice my PV is negative and my future value is positive. Those need to have opposite signs because it's money in, money out. And then I'm going to clear out this and say solve for N. And you might be going, whoa, that seems like a lot of years, except that's not a year number. That's 12,650.2 days. We want to turn this into years. So what do I need to do with that number? Well, I need to divide it by the number of days in a year. So 365. And from there, I would get approximately 35 years. So it's somewhere between 35 and 36 years would be an acceptable answer. This is a really sort of quick, nice, neat way to figure out my doubling time. Hopefully this helps you get going on this particular homework assignment. Check out the other videos to see some regular deposit problems. And yeah.